Hello everyone. So today we'll solve one LeetCode medium problem, Maximal Square, and this has been again asked in almost all good companies: Facebook, Apple, Amazon, Microsoft. This problem is similar to the previous problem which we solved, named as count a square submatrices with all ones. This problem is an extension on top of that. So we can just look into this problem and we'll see how we can solve this. And we just need to think of the previous approach as well. So it says given an m cross n binary matrix. So we have m cross n binary matrix filled with zeros and one, and it says find the largest square containing ones and return its area. So we need to return the area of the largest matrix. So if we'll see the basic thing, just to know that what we can do, we can start from the start, go one by one and see what can it be of one of the largest matrix. So if you read this, this could be part of 1 cross 1 matrix. Can this form a 2 cross 2 matrix? It can form, but not all the numbers are 1. So the largest matrix of all 1 would be here 1. Similarly here again 1. These are zeros. This will again contribute for only 1 cross 1 matrix. If you're at this place, we can see this can contribute to 1 cross 1 as well as 2 cross 2. It can't contribute to 3 cross 3. If you see here or here, we have a 0 here and 0 here, right? So we can see the maximum it can contribute 2 cross 2. Same way for here as well, we can see it's again for 2 cross 2 maximum. But these and these numbers also, like these three and these three are like they will be contributing to 2 cross 2 matrix. So till here, like if we see, we have maximum 2 cross 2 matrix. This one will be again maximum 1 cross 1, and this will be again maximum 1 cross 1. That's the reason our final answer is going to be 2 cross 2, which is the area of 4. So if you see, the area is 4. We had to return, area. So that's the thing, and let us see what we can do to solve this. So I would recommend highly to go through this video because that has the clear understanding, like how do we count all the subsquares of the matrix. So that's the only thing we need to do. We need to do and see count all the sum matrices, and then out of that the maximum sum matrix which can contribute, we have to just return it. So this is an extension on top of this. But let's quickly understand the problem and solution if we can think of. So just assume, let's say if you're starting from this very first 0, 0, right, and going in one by one direction. So just to reiterate what we can do, if you're at this place, we can think of like what all maximum matrix of one, this one can contribute. So this can contribute to 1, 1. Can we see like can it contribute to 2, 2? So again, like if it's, since we are starting from this place, right? So we'll be starting with one for loop. And then again for this all numbers, we have to just see can it contribute to 2 cross 2. So we'll see again, yep, this can contribute. And for the same number, can this contribute to 3 cross 3? So yes. So the maximum matrix this can contribute is 3 cross 3. But this will take the more complexity, because at this place, if we are starting from here, we don't know the next numbers. So if you see, if it's making certain the matrix, what it does, like this basically belongs to the left corner, right? Top left corner. And so in matrix, we can have top left and top right corner as bottom right corner as well. So just assume if it's the bottom right corner, can we say like if you're at this place, or let's just assume for this number, if you're at this place, we have read these numbers and these, like we don't know the future numbers, right? These numbers we don't know. So based on that, can we know like what could be the maximum matrix till this place, it can contribute? So yes, like this can contribute to 2 cross 2 because we don't know the future numbers. And if it makes the 2 cross 2 matrix, then definitely it will be the bottom right corner, right? So that could be the same logic, we can just think of when we are reading each number. So if you're at this place, what could be the maximum matrix it can create? So this can till this point, we know this, we have read only this number. So this will be for 1 cross 1. So we can just go and update 1 because this is the maximum matrices it can be part of that maximum matrix. Similarly, this number will be again part of 1 cross 1 matrix because this will be again, right? This can, so not a square, this is like forming, what do we say, rectangle. So rectangle we can ignore. The square would be like this 1 cross 1. Similarly here again, this would be 1 comma 1 square matrix. So again here, we can write 1. This we can ignore because 0 we don't need to care. If you're at this place, this will be again 1 comma 1 square. 2 comma 2, we haven't read this number at this place, right? So we can just write 1 comma 1 here as well. When we come here, we can know that this can form a 2 cross 2 matrix, right? And how do we do that? So here it will become 2. So the very first number, like we know, if we read any number 1, so that will be part of 1 cross 1 matrix for sure. So 1 is coming because the moment it has 1, we know that this belongs to 1 comma 1 matrix. And from this picture, we know that this is belongs to 2 comma 2 matrix, right? So how this extra 1 is coming, right? So this extra 1 is coming based on these three numbers, right? Because if it has to be 2 cross 2 matrix, then these three numbers should belong to that 2 cross 2, matrix, square matrix. So that's why this extra 1 is coming, any of the three numbers. So how does it come basically, this extra 1 here? Like, how do we know that this belongs to 2 comma 2? So we check the minimum of these three numbers, the previous three numbers. So 1 comma 1 comma 1 would be 1 only. So that's why the answer is 2 here. Similarly, here answer would be again 2 because 1 plus minimum of these three, 1, 2, right? If we come here, this place. So here, let's just write 1 comma 1, right? So that's the answer 2. Here again, the answer would be 2 because 1 would be this and the minimum of these two, right? So here how it's coming, 1 is basically because this self number is 1 cross 1 and the minimum of 1 comma 1 comma 2 is 1. So that's why 1 plus 1 is 2. Same here, it will be 1. So if you see the first row and first column, the numbers can be at most 1. And in the second column or second row onwards, these numbers basically get changed. Here again, it will be 2 because 1 plus minimum of these would be 2. If you are at this place, so answer would be like this can belong to 3 cross 3 matrix, right? It's maximum. So how does this come? 1 is basically, this is coming because this number itself is a 1. So we know that it belongs to 1 cross 1 and min of 2 comma 2 comma 2, right? So these numbers are 2 because they maximum belong to 2 cross 2. So this can belong to minimum of whatever the number is coming, right? So 1 plus 2, that is 3 cross 1 plus 2. So that's why here we know that this belongs to 3 cross 3 matrix. And let's assume if here we have a 1, so that will belong to 1 cross 1 matrix. So now out of these 1, 2, and 3, the maximum matrix is 3 cross 3. So that's how we are going to solve it. So just to reiterate, for the very first row and first column, the maximum, it can contribute is 1 cross 1 matrix. And for the remaining rows and column, which is not, I equals to 0 and j equals to 0, it basically checks like sum of the, like 1 basically belongs to this current matrix number and the previous three numbers, the minimum of three number, we just add it and, then we know that this cell belongs to whatever the maximum matrix. And we can just update it here if needed, right? So let's try to write, the same program and we'll see how it goes. So let's say let max square equals to 0. Then start, just going through the matrix. Yes, then matrix dot length. And I will also, add the URL of this question, which we have solved into the same description. You can just look into that. This would be less than matrix I dot length, J++. Now, how are we getting the answer? We are getting the answer, like we're trying to add the answers if we are not in the first and first column, right? So we should always have the numbers as well as, let's say, if you're not in the first and first column, then you're adding those values. So how do we do that? If I and j, that means we are not into the first row and first column, then we are adding these numbers, right? So what we do, and matrix of I comma j, right? So if the number is also there, because for the 0 we don't care it. That won't be contributing to for the matrix square. So we say matrix of I comma j equals to whatever the current number I do have, which is basically 1, right? If I'm at this place, let's say, so this number plus sum of these three numbers, so whatever the minimum I get at these places, right? So plus math.min matrix of I comma j minus 1 or matrix of I minus 1 j comma matrix of I minus 1 j minus 1. Cool. That's it. And then just we need to check whether this whatever the current number we got, and in the our max square, whichever the maximum, we can just update it. So how do we do that? Let's do it here itself first, and we'll then see why. Now we'll see max square is equals to math dot max of my current number or matrix of I comma j, right? So here what we are trying to do, we initialize the max square with 0, and let's say at every place we are replacing this current matrix cell with the maximum, this number, whatever we got, right? And you're checking whether our max square is equal to 2 or not. So till this place, like max square will have the 2, the moment it will come to this place, it will get updated with 3, right? So that's what it will do. But there's a catch. Let's say what if all the numbers are getting zeros here, right? And we have all the numbers 1 into here, these row or this column, right? First column. Then the max square should be 1, right? Max square should be 1. Because we know that here definitely it could be 1. But we have initialized our max square with 0, and this loop is only running for, if we are not into the first column, right? We're checking if here I and j is there, like it's not 0. So instead of adding it here, can we move this block of code from here to here out of the if loop? So let's say even if I equals to 0 and j equals to 0, we are going to update this max square with nothing but this will be 1, right? In the first column, those numbers are already 1. So 0 comma 1. So max square will be updated with 1. And let's say if you are done with this calculation inside this block, so this matrix of I has already been updated, and the same will be put here. Let's say if it's 3 or 4, that will be checked with max square, right? So instead of adding this condition here, we can just update it here, and then we should be good. Let's try to run it. So we are getting undefined. Okay. The reason could be like these numbers, the input are basically string instead of number, and we are trying to add those numbers. So at each place, where we are trying to do some addition or calculation, we need to convert them. So first we are trying to see here whether we have the number here or not, like whether the matrix of I comma j equals to or not. So first convert this string to the number, right? So at every place, like here we are trying to add those numbers. So in JavaScript, I'll just try to write it in JavaScript. If you add 1 plus, let's say 1, so that should return 1 1, right? So in few test cases that won't pass, so we need to convert them to the number. So like this one we have to convert to this, so that's why we can do certain mathematical operation on top of that. So let's change this to number. Similarly here again, number of matrix from I comma j plus each place where I have this matrix written. We just need to convert them to the number first. And here again. Right, we got it. And then math.max. So numbers, like we're converting to the number and then adding it here. So here we should be good. Okay, and we had also not returned this max square, after this for loop. So we had to return this max number. So this undefined was because we were not returning anything. Now let's try to run this. Answer is 2. We're expecting 4. Okay, because we have to return the area. So area would be max square into max square, right? Instead of the max square, we just need to return the area. So yes, now let's try to submit it. Yep, it got accepted. So that's it for today. We'll try to solve the next problem in next